Hello and good morning everyone. I'm Eric Ananawem, a final year student from Information System Program from Faculty of Computer Science and Information Technology, UNIMAS. So today I would like to present my final year project for the semester 2024 and 2025. But first, I would like to thank my supervisor, Dr. Sarah Flora Anak Samsom Joan, and also my examiner, Dr. Lee Nong Kyun, for the time of reviewing my presentation video for the final year project. So the title for my final year project is Emotion Recognition from Adult Speech Using Machine Learning, a study based on the Kirimadi dataset. So for the chapter 1 or introduction to the research, before going into details like problem statement, project scope, objective, and also the expected outcome, I would like to briefly talk and discuss about what is speech emotion recognition. So speech emotion recognition or SER refer to the ability of the system or machine to understand and interpret human emotion through speech. This means that the machine have the ability to analyze the vocal characteristic or features in spoken speech by humans. These attributes can include things like tones, pitch, energy, and also the intensity. So this machine ability is increasingly important in areas like mental health monitoring and also customer services. For example, in mental health domain, SER or speech emotion recognition can help psychiatrists to recognize and identify emotional changes in patients, and this helps to prevent any mental health issue from getting worse. So why I choose this topic and what it contribute to the whole general landscape of AI is first is the growing importance of SER in human computer interaction or HCI. So the ability of machine to recognize emotion can improve the way of human interact with machine by enabling system to understand and respond to human emotion effectively. In other words, in making AI a more human-centric. So the second point is the opportunity to develop speech emotion model in automatic speech recognition or ASR. As we know, ASR is transcribing spoken language into text. So by integrating speech emotion recognitions, it helps to add an additional layer by analyzing the emotional tones behind the speech, which providing machine with a deeper understanding of user sentiments. This also helps to create a more initiative and responsive human-computer interactions. So now, I would like to play two audio clips from speech emotion dataset. There is two types of audio clip. The first one is the angry emotion audio clip, and the second one is the happy emotion audio clips.
It's 11 o'clock! Maybe tomorrow it will be cold.
So from these two audio clip, we can hear and understand that different emotion have different characteristic in the vocals. For example, anger emotion have a higher pitch or intensity when expressing the anger. This vocal characteristics is important in speech emotion recognitions as it is one of the key components for the model to recognize the emotion effectively. So the problem statement for this research is first is the variability in speech is influenced by few factors including personal emotional expression, background noise, voice accent, and linguistic diversity. The second problem statement is the challenge in determining and choosing the suitable deep learning architecture for SER models. The third problem statement is the existing dataset used for training and testing emotion recognition Models often do not reflect the variability of emotional expression found in real-world speech. This problem statement has led to challenges in developing a reliable and effective speech emotion recognition model. So the objective of this research is first to analyze the deep learning techniques, including CNN, convolutional neural network, LSTM, long short-term memory network, transformer, and hybrid approach for emotion recognition. Second objective is to develop an acoustic model or SER model that able to recognize emotions from adult speech using CRIMA-D dataset. These emotions include emotions like happiness, sadness, anger, surprise, and etc. The third objective is to test the performance of the acoustic model using key metrics like accuracy, precision, recall, and F1 score. And finally, to benchmark these SER models against the existing study to identify the best deep learning technique employed in speech emotion recognition. So the next for the research scope is cover first explore on the deep learning architecture in SER and analyze the effectiveness of each architecture in recognizing emotion from speech by reviewing and doing comparison of previous or existing study. So next is a SER model will be developed based on the recent trends of deep learning architecture and achieving accuracy of SER models that have been tested in the previous study. This project will utilize the CRIMA-D dataset, which consists of 7,442 labeled audio clips with variety of emotional expression, which will be used for this model training and also testing. Fourth is the project will employ evaluation metrics such as accuracy, precision, recall, and F1 score to assess for the model performance that have been built. The last one, or the fifth one, is to benchmark these SER models against the existing or previous study. So what do we expect, or the expected outcome from this final year project is first, to able to deliver an acoustic model derived from one of the deep learning architecture that will be capable of recognizing emotion from the CRIMA-D testing dataset. Second is to provide a practical insight and recommendation for further emotional identification study. So next for the second chapter or literature review, it consists of several components, which first is the review on the foundation of speech emotion recognition. This includes the review on the evolutions of machine learning techniques such as hidden Markov models. The second component or the second review is on deep learning architecture in speech recognitions like CNN, LSTM, transformer, and also the hybrid approach with combining two of these deep learning techniques. The third one is the review on common feature extraction for emotion recognitions. It consists of FCC, log mass spectrogram, and also the prosodic features. So the fourth review is on the overview of the speech emotion dataset. And the fifth one is the evaluation metric in SER, which consists of precision, recall, accuracy, and also F1 score. So this is the comparison table or review and on the previous study. That is, the review consists of seven papers, which comparing few different deep learning architecture. For example, there is CNN, LSTM, and also the hybrid approach with combining CNN and LSTM. All this research has using different kind of feature extraction technique, and also for the dataset that has been used is more or less is the same, which is UMOCAP, MODB, and also RAFDS. This dataset is the commonly used dataset for speech emotion recognition model training and also testing. From this review or comparison of study, we can see that CNN and LSTM hybrid approach has achieved the highest accuracy in recognizing emotion, which is 98.91 on EmoDB dataset, and also 95.33 on EmoDB, and also 92.34 on EmoD dataset with one-dimensional CNN and LSTM. So next, for the chapter 3, which is the methodology of this research or methodology of implementation of the SER models. So first methodology is the data collections. For the data collections, this research has utilized a CRIMA-D dataset, one of speech emotion dataset that commonly used for model training and testing. And also, this dataset is open source dataset and can be downloaded from kaggle.com. So second methodology is data transformation, which consists of data splitting and also label encoding. For data splitting, the dataset is split into training and testing subset. 80% of the data are used for training, and while the remaining 20% data is used for testing. So for label encoding, it is converting categorical emotion labels into numerical value that can be used by machine learning models. So the third methodology is the data augmentations. This is to increase this data augmentation is to increase artificially the size of training dataset by creating a modified version of the original audio samples, as deep learning model often require a large amount of training dataset to perform effectively. Meaning to say, if the dataset is not big enough, it may lead to a poor model performance. So the feature extraction used is the log-mail spectrogram. Log-mail spectrogram is a time-frequency representation of an audio signal that transforms the raw audio into a visual spectrum. This means that mail spectrogram converts the raw audio into a 2D representations. It also has a feature because its ability to capture key prosodic elements such as pitch, energy, and speech rate. In a mail spectrogram, by converting the amplitude of frequency into logarithmic scale and using a filter bank, the mail spectrogram effectively highlights the emotional nonsense in speech. So by referring to the previous study on speech emotion recognitions and then achieving accuracy in CNN and LSTM hybrid approach is the highest. So this study will also employ the same hybrid architecture, which is CNN and LSTM. Specifically, it will employ a two-dimensional CNN. So first, the input audio, which the audio file has been transformed into spectrogram or time frequency presentations, will serve as an input to the convolutional layer. The convolutional 2D layer will apply a set of renderable filter, also known as kernel, that will slice over the 2D input and extracting the local time frequency pattern that are required for recognizing emotions. Next layer will be batch normalization and activation function. Batch normalization helps to maintain consistent feature distribution throughout the training. This will lead to a faster convergence and help in model stability. While activation function introduces nonlinearity into the models, allowing it to learn complex patterns in the data. After that, the 2D max pooling will perform a downsampling on the feature maps generated from the previous convolutional operation to reduce the dimension while also returning the significant features. This is to enhance the computational efficiency and also reduce the overfitting. Next, the LSTM layer will follow to capture the sequential dependency in the audio data. This is crucial to understand the emotion changes over the time. Finally, the fully connected layer will interpret the learned feature and classify emotion, with the last layer utilizing a softmax activation function to output the probability for each emotion class. So for the evaluation metric of this SER model, it consists of precision, recall, accuracy, F1 score, and also confusion metrics. So there is several requirements that need to be fulfilled to implement this model. So first is the programming language. It need to be Python version 2.0 or above. For the APIs, is a TensorFlow and Keras API for model deep learning model building. So the tool and platform is the Jupyter Notebook and can be also Visual Studio Code. So for the library, there is total of 6 library: Librosa, which is used for audio processing and feature extraction; NumPy for numerical computation and array manipulations; Matplotlib for visualizing data and performance metric; scikit-learn for model evaluation; Pandas for data manipulation and analysis; and finally the Seaborn for plotting, conversion metric, and the performance visual. So for the hardware requirement, for the CPU, it need to be AMD Ryzen 3. For the graphic card, it is NVIDIA GTX 1060 or equivalent. For the RAM, it need to be minimum of 8 GB or above. And minimum for the lower RAM will cause a longer waiting time in program execution and model training. So for the storage of the computer need to be at least 250 GB of free space. The operating system must be at least in Windows 10 or Ubuntu 20.04 or the latest one. So for conclusion for this final year project 1, chapter 1 has established the research foundation, outlining the problem, objective, and the scope and the completion of this study, while chapter 2 reviewed the theoretical and empirical background of SER, covering the system workflow, application, deep learning architecture, and reviewing on the previous study. This established a clear framework for designing in the project SER model. So the third chapter is the detailed methodology, including data collection, data transformation, data augmentation, feature extraction, and the proposed hybrid CNN LSTM model architecture. And also the evaluation metric to ensure the proper performance analysis. So for future works, in the upcoming chapter 4 in FYP 2, the methodology and the theoretical framework established in the previous chapter will be translated into a practical applications. So first, there will be a model development and training, which the hybrid speech and motion recognition model will be implemented. The model will be trained on Crimadi dataset. Next is the testing and evaluations. The trained model will be evaluated on unseen data from the Crimadi, and also to assess the model reliability in recognizing emotional state based on performance metric. So third one is the comparative analysis, is to benchmark the proposed model against the existing study or previous study. So that's all for my presentation for FYP 1. Thank you.